Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapkot. Dear students, in the previous class we were discussing numerical on conduction heat transfer. That on Fourier's law of conduction equation. So now I will move towards next problem. I will read the problem first. A plain wall is 150 mm thick and its wall area is 4.5 meter square. Full stop. If its conductivity is 9.35 watt per meter degree Celsius and surface temperature are steady at 150 degree Celsius and 45 degree Celsius. Determine first one heat flow across the plane wall. Then second one, you have to calculate the temperature gradient in the flow of heat direction. This is the problem he has given, dear friends. So you have to solve the numerical. Then how to solve this numerical? As I told in the previous class, if you want to solve this numerical, first what I have to do, I need to draw the schematic diagram. So I will draw the schematic diagram and I will try to list out the given data with respect to diagram. So now what actually is telling, there is a plane wall is there, that is 150 mm thickness. That thickness I will mark here, dear students, dx. I will take notation, thickness of plate I will take it here, dx, and that wall is having an area, that area I will take mark as a, that is 4.5 meters square he has given. And that plate or a wall or a plane wall, you can consider it is having a thermal conductivity. That thermal conductivity I will represent it as a K actually, and that he has given, that is 9.35 watt per meter degree Celsius he has given. Okay, and surface temperature are steady. That means what? One end is high temperature region, that is 150 degree Celsius. Another end is low temperature region, that he has given 45 degree Celsius. That means what? So high temperature region, as I told in the previous class, dear students, what I will do, I will mark here as a T1 and T2. So here I will mark here high temperature region as T1, low temperature region I will mark it as a T2. So he has given T1 and T2. So with help of this data, you need to calculate the amount of heat transfer. That amount of heat transfer is represented with a notation. Just a minute. The amount of heat transfer, you can see here now, the heat is transferring from high temperature region to low temperature region. So that heat transfer is represented as a Q. So that Q is equal to how much? First question. Second question, if the temperature is getting decreased, right, along the thickness of the plate. So how much amount of temperature is getting decreased along the thickness of the plate he is asking. That is what? Second finding, dear students. Now, so now what I will do here now, first what I will do, I will list out the given data. So what all things he has given, list out, dear friends. So there is a plane wall is there, that thickness he has given. So what I will do, that thickness I will take it here as a dx. Okay, so dx is equal to how much he has given? 150 mm he has given. So convert it into meter, it becomes what? Dx is equal to, it becomes 0.15 meter. So 150 divided by 1000, we are going to get 0.15 meter, you can mark. Okay, and area is equal to how much he has given, dear students? That area you marked as a A here now, that A is given in the problem itself, that is 4.5 meter square he has given. Fine. Next, if the thermal conductivity, that thermal conductivity he has given as a K, right? That K is equal to how much? So he has given 9.35 watt per meter degree Celsius. Dear students, sometimes he will give watt per meter degree Celsius or sometimes he will give watt per meter Kelvin. So unit should be, you have to take care. Okay, next, surface temperature. So high temperature region, you can take it as a T1 is equal to how much you can take? 150 degree Celsius. Then T2 you can take, dear students, final temperature 45 degree Celsius. With the help of these two data, what I can do, I can calculate the change in temperatures. Change in temperature, how I can take? Highest temperature minus lowest temperature, final temperature to the initial temperature. That is nothing but what? T2 minus T1. So therefore dt is equal to how much I can write? T2 is nothing but what? 45 minus T1 is equal to 150 degree Celsius. So what I can do here, dear students? So now what I will do, okay, so now what will happen now? 45 minus 150, that is 105. So minus, so therefore what I can do here now, so therefore what I can do, dt is equal to minus 105 degree Celsius. Okay, fine. Now what all things he has given this now. So first what I have to do then, now I have listed the given data. Now I need to solve this problem. So first parameter is what? Heat transfer. So that is nothing but what I will mark here, heat transfer. That heat transfer is represented as Q, right? So heat transfer is represented by notation, that is Q. So to calculate that Q, we are going to use a Fourier's law of conduction equation. What is that? Minus Ka into dt by dx. Okay, so now you substitute the value to calculate the heat transfer. My first finding, you can write it here now, findings. What are findings now? My findings are, first one, heat transfer, that is Q, is equal to how much? Second finding is how much, that is temperature gradient. The temperature gradient is nothing but what? Dt by dx is equal to how much? This is my second finding. So what I'm doing now, I'm going with what? First one, that is heat transfer. That heat transfer is nothing but what? Q is equal to minus K into dt by dx. So that I can calculate here now. So I will keep minus as it is. What is the value of K? K is nothing but what? He has given in the problem itself. How much? 9.35 into, what is the area? Area he has given as a 4.5 into, what is the change in temperature? Again, you can take it here now, minus 105. So I will write it here, minus 105 divided by, what is dx? Dx also has given thickness of the plate, that is 0.15, dear students. Now do simplification. So calculate. So now what I will do, now minus into minus it becomes plus. I will not consider here. So 9.35 into 4.5 into, what I can do now, that is 105 divided by 0.15. What is the answer, dear students? You can see here now. That is, so therefore Q is equal to how much I can write? Q is equal to 29. What is the answer? 29452. 2.5 watt. This is what? Heat transfer. This is the heat transfer. We got it now. We can express that in terms of kilowatt by dividing 1000. Okay, first parameter is over. So second one, what is second one? I will go with that second one. What is that? Temperature gradient. Second one, temperature gradient. Temperature gradient. That is nothing but what? Dt by dx. So how to calculate that dt by dx? Again, with help of what? With help of an equation. What is the equation? Fourier's equation. That is what I want, dt by dx. I will rearrange this equation. That is nothing but what? So therefore what I can do? Dt by dx. I will write it here. So what will happen now? Dt by dx. Then Q divided by K into A. Whereas minus sign is there, minus sign will be left out. So therefore what I will do? I will try to substitute the values now. So therefore dt by dx is equal to, what I can do? What is the value of Q? Q already we calculated here now. So I will write it here, minus 29452.5 divided by, what is the value of K? K is given, right? That is how much? 9.35 into, what is the value of K into A? A is equal to how much he has given? 4.5 he has given. Do simplification, dear students. How much you are going to get? Okay, so now I will do here now. 29452.5, okay, divided by 9.35 into 4.5. How much you are getting? You are getting 700. Here minus is there, so minus 700 you are getting. So therefore what we can say now? What we can say? So therefore dt by dx is equal to minus 700. What is the unit now? Watt. It is what? It is in degree Celsius, right? Degree Celsius divided by meter. So degree Celsius divided by meter. This is what? Final answer. Second answer. So here you can convert this also. It is watt per. So now here it watt per. It is Q is watt. K is watt per metric Kelvin or metric degree Celsius. A is the area, meter square you can cancel, then we are going to get the final answer is degree Celsius per meter or degree or Kelvin per meter you can get. This is a final answer. This is how to solve the numerical. We'll continue in next class. Thank you.